Hi, how are you? I hope you guys are doing great out there. Today, I just want to cover the most important thing for today's lecture, which is the conservation of momentum. The This conservation momentum principle usually is used for two objects or more than two objects when those two objects they're colliding with each other, and then the colliding force actually, if we consider those two objects as one system, so the colliding force between those two objects become internal forces. So when external forces actually is zero, so we can use conservation of momentum principle. Uh, there are different kinds of collisions actually in the conservation momentum principle application. One is called elastic collision, the other one is called inelastic collision, and there's one more which is called completely inelastic collision. So the elastic collision means that when two objects collide with each other and then there's no energy lost. But inelastic collision means that there is an energy loss due to the collision. The most important thing I want to illustrate today here is actually you can read the PowerPoint file I uploaded to the Blackboard, and also you can watch the video I posted through the Khan Academy, and as well as please read the textbook. I gave 2 sections of reading assignments for this particular topic. But here I want to give you one example of how to use the conservation momentum principle to solve problems. So the major thing here is when we say momentum is conserved, we're talking about a system momentum is conserved. So let's say if you have two objects, object 1 and object 2, they collide with each other. So we need to calculate the momentum for both objects before the collision and after the collision. So net momentum before collision equals net momentum after collision. So for example, if you have two cars, this is 5 kilograms, is moving at 10 meter per second. The other car is 1 kilograms, which is not moving. Okay, so then they collide with each other, and then they stick together. So this is before, this is after. So when we have collision here, we usually consider the moment before the collision, the moment right after the collision. So what is the total momentum before and after? So before is 5 times 10 plus 1 times 0 equals, okay, because they stuck together, so they have total momentum of 6 kilograms, and then we can find out the velocity. So the velocity actually you can calculate is 1.33 meter per second. So that's how you deal with momentum conservation principle problem. Okay, so I can give you another example. So for instance, so for this case, the car is moving this direction, this car is moving this direction. Instead of at rest, it moves 4 meters per second to the left. Remember, momentum, they are vectors. So when we calculate momentum, so you have to remember how we do vector additions, vector subtractions. So you have 5 times 10 minus 1 times 4 equals 5 plus 1 times v. Okay, so you have 50 minus 4 here, is 46 equals 6v. So v equals 7.67 meter per second. Okay. So that means these two cars, they collide with each other, and then afterwards they stick together. They're going to move at 7.67 meter per second to the right. Okay. So you can do similar problems. You know, there are more examples from the textbook, and also again there are some examples from the Khan Academy video. If you guys still have any questions, you can post a question through the discussion board, and then I will answer the question through the discussion board. I think that's this is the most important thing for today's lecture.